Okay, so we're gonna look at law of sines today. Uh, Last class we looked at triangle that they were right triangle, and we worked with those, and we tried to find out the missing sides in that. But what happens when the triangles are not right triangle? What if the triangle is obtuse triangle or acute triangle? How do we find the missing sides for those type of things? For that, we use law of sine. This is the law of sine. So let's say for any given triangle, you get A, B, C, A, B, C. You get proportional argument. Sine of A over A equals sine of angle B over B equals sine of angle C over C. Technically, you could also use it for right triangle too. You'll get the same answer no matter what. So let's look at it. Let's do some problems. So let's say if I give you this triangle, 60, 40 degree, you have 4. This is the angle C, C, B. So we want to find the missing side. Right away, we could figure out this missing side. Because 180 minus 40 minus 60 gives you what? 80 degree. So right over C is 80 degree. What are the missing sides? So we put sine of 80 over C equals sine of 40 over 4. So I get 4 times sine of 80 over sine of 40 equals C. And roughly C is going to be, you use the calculator, make sure your calculator is in degree mode. C is going to be 6.13. So let's try another problem. (15°), 35°, 5, A, and B. Let's try to find those. And again, we're going to use law of sine. So it's super easy again. What's the missing angle? Missing angle is 130°. So 180 minus 15 minus 35 gives you 130. So now let's use this. Sine of 130 over 5 equals sine of 35 over A. So A equals 5 sine of 35 and you get sine of 130. So approximately your A is going to be 3.74. Now, what about the other one? Sine of 15. Let me write it like this way. B over sine of 15 equals 5 over sine of 130. And you will get the same answer too. So this is a little bit easier because I have to do less cross multiplication. And B approximately will equal 1.69. Now the following problem is a little bit tricky. Here's the reason why it's tricky. Here's the reason it's a little bit tricky. It has to do with sine inverse function. So solve the triangle. If I say A is 6, B is 8, and A is 35. So AB, let's do it this way. That's B is 8, A is 6, this angle is 35. So I want to find out all the missing sides, like this one, and so on. Now, here's the trick part, why it's happening. Let's go back to the sine inverse. Where does the sine inverse live in? Sine inverse lives in from negative pi over 2 to positive pi over 2. That's the crucial part. Because of this, when we use law of sine, you could get two possible answers. Let's go back again. Since sine inverse lives over here, this is what we could call this no, I'm sorry. That's not for sine inverse. It has to do with sine. Sine is positive in the first and the second quadrant. Sorry. Because sine is positive in the first quadrant and the second quadrant. This. So you get from 0 to 180 or 0 to pi. That's where we have the issue. Here's the reason why. I'm going to come back to this. Let's start this problem. Let's use sine of 35 over A equals sine of angle B over B. And A is, oh, we know A is 6. So if I do that, I get what? B equals, oh, sorry, B is also 8. So sine B equals 8 over 6 sine of 35. So B equals what? Sine inverse of this whole thing. Okay? So when we do that, so we got to ask ourselves, sine of what gives you this angle? And sine is positive in the first and the second quadrant. Let's do the first one right away. So if I do it right away, 8 over 6, you get roughly sine inverse of 0.76. So the angle B is 49.9 degrees. So that's one of the angles. Now this is what I'm going to do. I'm going to take, that's one possible angle. The other possible B2 angle would be, take this, subtract it from 180. And also subtract that from 35 degree because that's my possible angle. Oh, sorry, not quite. Sorry. Subtract that from 180. 180 minus 49.9. I get possible angle over here is 130.1. We're going to come back to this angle in a bit. So for that angle B1, we got angle A to be 35 degree. Now what's angle C? And that's what we do it. 180 minus 49.9 minus 35, and it will give you 95.1 degree. This all works out nice because when I add them, I get 180. So I have angle A, angle B1, which is 49.9 degree, and angle A is angle C is 95.1 degree. Now what's missing over here is missing the side C, and we could easily do that. Side C is gonna be sine of 35 over 6. I could have used 49, but I like whole numbers. Then sine of 95.1 over C. That's the possible one. So C1 equals 6 times the sine of 95.1 over sine of 35. And approximately C1 is going to be 10.42. So these are all the possible answers for this triangle. What about for this angle? Right over here. What do we do with this one? If this angle is B2, so what's the possible angle for C2? You get 180 minus 130.1 minus 35 degree, and you get 14.9 degree. So we got our 14.9 degree. Now can we find the missing side? It's super easy now. Sine of 35 over 6 equals sine of 14.9 over C2. So C2 equals 6 times sine of 14.9 degree over sine of 35. And roughly, it will equal to 2.69. So here's the reason why you can get two possible angles. When I gave you this measurement, 35 degree. This side C, 6. It could be this one, or it could be this one, 6. And you have this possible two triangles going on. This is the first possible triangle, and the other possible triangle is 8, 35, and 6. So we're finding the missing sides for these two type of triangles. That's why you get two possible answers. Now, we're going to look at a problem how you cannot have second triangle. What if I give you the triangle? A is 3, B is 2, and A is 40. So let's look at it. 2, 40 degree, and 3. Well, technically, you could have this also going in like this way and call it 3, but we're going to see that that second triangle is not possible. Here's the reason why. Let's look at sine of 40 over 3 equals sine of angle B over 2. Sine of B equals 2/3 sine of 40. And if we just do the calculator, roughly sine of B equals 0.43. So B equals then sine inverse of 0.43. And that will give me, I'll get that possible B1 angle would be 25.4 degree. Now, what about B2 angle? B2 angle would be 180 minus 25.4, and you'll get 154.6. And we're going to see why this is not possible, why this is not a good one. Here's the reason why. If B2 is 154.6, and we know A is 40, what about angle C then? So 180 minus 154.6 minus 40. That's the problem right there. This is already greater than 180. So you cannot have a second possible triangle. So we could just stick to this, and right away, angle C would be 114.6. So sine of 40 over 3 equals sine of 114.6 over C. So C equals 3 times sine of 114.6 over sine of 40. So angles, sorry, not angle, side C is going to equal roughly 4.24. Now, here's the reason we like law of sine. Let's look at some application problem for this. So let's say there is some mountain all the way over here. And obviously we can't climb that mountain all the way up. It's very difficult. But with your measuring tool, here you're standing, and you could calculate the angle of elevation. And let's make that 47 degree. And then what you do is you step back a little bit more, and you step back, let's say 900 feet. And you do the angle of elevation. Oops. You do the angle of elevation again. Why can I not draw a straight line right over here? And I get that to be 35 degree. Using law of sine, I could easily find out the height of that triangle. It's super easy. Let's say you're 6 feet tall. Let's figure out the height of this mountain. So we're going to use law of sine. Let's create the triangle right over here. If this is 35 and outside is 47, this is going to be 133 degree. And this is your 900 feet. Using that, all we need to do is figure out one of this side. Once we figure out this side, then let's say if I use this one, this is 35 degree. And if I know this missing side, I could use tangent to figure out the height. SOHCAHTOA's tangent, no, sorry, sine to figure that out, because opposite over hypotenuse, and I could figure out this height. So let's figure out this missing side. So in order to do that, I got to know the measurement of this angle. And that's super easy. 180 minus 133 minus 35 gives you 12 degree. So I could use sine of 12 over 900 equals sine of 133 over, let's call that C. So C equals 900 times sine of 133 over sine of 12. Approximately C will equal 3,165.86. Now we have this nice triangle. Oops. Let's go back to this one. If this is 3,165.86, what's the height then? We could use sine of 35 equal opposite, which is h. Let's call it a over the hypotenuse. So a equals 3,165.86 times sine of 35. So the height would be roughly 1,815.86 feet. Okay. All right. That's my lecture for today. Email me if you have any question.